am going to start the recording, and I will share my screen again. And we're going to begin today's discussion with confidence intervals, but the difference between today's discussion and the discussion from last week is that, at least in the initial presentation, we're going to focus on where the population standard deviation is not known, which leads us to a discussion of what are called T intervals. Okay, last week we talked about Z. We use Z intervals whenever we know the population standard deviation, and we use T when we do not. But you're going to see a lot of similarity between the two concepts, because it's not different, it's not a new concept, it's just one with different requirements. So a T interval has really the same conditions that we had previously. With the Z, you still want to check to see if the following two statements are true. And again, normally it's going to be somehow noted in the problem. And if it's not, for our purposes, we assume that is the case. And that is that there is a simple random sample, and our sample size is greater than 30, or we know that the population is normally distributed. In the scenarios, you're going to be given a lot of the same information. You still get the sample mean, you're still told the sample size, and you're still told the confidence level as a percentage. What is different is that you are given the sample standard deviation, not the population standard deviation. We have the same two type problems where you're either given the summarized sample statistics, or you could be given the raw data, similar to the two type problems we had last week. I left this particular slide blank because I wanted to backtrack a little bit, but also move forward. Again, last week we talked about confidence intervals, which, again, remember, confidence intervals give us a range of possible feasible values for the population mean, rather than relying on a single point estimate as we had been doing earlier in the term. And so we focused on confidence intervals where the population standard deviation is known. Remember, the population standard deviation is represented by the Greek letter sigma. And when that is the case, we create or construct what is called a Z interval. And I realized as I was preparing the lesson for today that we didn't really talk about what distribution the Z interval is based on. We talked about how we have to have our Z value for Z over alpha over 2, but I don't know that I really intentionally told you what distribution that's based on. The confidence interval for the population standard deviation being known, we call it a Z interval because we are basing our estimate on the normal, or it's sometimes referred to as the Z distribution. If you'll recall from earlier discussions, our normal distribution is a continuous probability distribution with the mean in the middle. Okay, it is symmetric. I was trying to remember the other thing. So it's based on the normal distribution. And I had given you the values that you might possibly need when you're calculating the sample size estimate. The rest of it, Minitab does for us behind the scenes. Today, in this discussion, we're still talking about confidence intervals. But now the population standard, deviation, which again is sigma, is not known. Typically in this scenario, we're going to know the sample standard deviation, which is S, is known or it possibly can be calculated. Okay, so that's the difference. And when you do not know this population standard deviation, we use what is called a T interval. And the T interval is based on a different distribution. It is based on what is called the student's T distribution. And we talk about these two distributions in Stat 1401, but you may not recall, but let me draw this and I want to be very intentional about it. Okay, the student's T distribution is very similar to the normal distribution. It is still bell-shaped. It is still symmetric with respect to the mean. Because it is symmetric, your mean, your median, and your mode are virtually all the same value. The difference between the Z and the T is that the T does not taper off as fast. Okay, so that basically we have more area in the tails. Remember, the tails are the end of the curve. And for a T, it doesn't taper off as fast. Typically, the T distribution was used or was created to deal with small samples, which are typically samples that are less than 30. The story behind it, not that you care, but the story behind it is that it was developed by a guy who worked for like the Guinness Beer Company in Germany. And of course, they were doing sampling to make sure, they were filling the bottles appropriately or, that everything was working the way it was supposed to. But they would take small samples. They may only sample maybe 1, 2, 3, 4, 5, or 10. And so the quality control guy realized that really the normal distribution where you had to have a sample size of 30 or more didn't apply because he was using smaller samples. So he worked and studied and developed this T distribution. Again, it has all of the same characteristics as the normal. It is symmetric about the mean. It is bell-shaped. It is continuous, but it was made to deal with those smaller samples. I think his name is out there somewhere, but because of the proprietariness of this development, Guinness wouldn't let him publish the work in his actual name because they were afraid it would get out that he was their employee. And so he used a pseudonym, much like Samuel Clemens uses the pseudonym Mark Twain, but the pseudonym he chose was student. And so that's why it's called the student's T distribution. Again, not that you care, but that's a little tidbit. But again, the primary difference is that the T distribution does not taper off or get close to the horizontal axis as fast, so that we have more area in the tails. So I just wanted to make sure that I clarified the difference between the two, but also make sure you know which distribution, which type of graph, if you will, these confidence intervals are based on. So we're focusing today on the ones where we do not know the population standard deviation, which are T intervals. I do have the mini tab keystrokes, whether you have the summary statistics or whether you have the raw data. And honestly, the only difference here is that we choose a one sample T instead of one sample Z as we did last week. That's the only difference in the command, is that now we have to tell Minitab that we want to do the T rather than the Z. The process for calculating the error bound for the population mean is the same. It is still the upper bound minus the lower bound divided by 2. And then the manner in which we write the conclusion is also the same. Your interpretation, your conclusion should always state the confidence level, explain what population parameter is being estimated. And again, for us, our focus is on the true population mean. And then you have to state the confidence interval by indicating both endpoints, both the lower bound and the upper bound, including the appropriate units. So again, a lot of what we're looking at today, at least in this part of the lesson, is pretty much the same as last week. We're just going to be given the sample standard deviation rather than the population standard deviation. So if we go ahead and kind of dive in and look at an example, and I did move the example over to our paper so that we could look at it and I can make notes, and then I'll send these out should you want them. Okay. It says, suppose that a committee is studying whether or not there is a waste of time in our judicial system. It is interested in the mean amount of time individuals waste at the courthouse waiting to be called for jury duty. The committee randomly surveyed 81 people who recently served as jurors. The sample mean wait time was 8 hours with a sample standard deviation of 4 hours. Construct a 90% confidence interval for the population mean time wasted. So one of the things that I notice as I'm reading this particular statement or this particular scenario, and again, it's important you read it slowly and carefully. If we check our conditions, it does tell us that we randomly surveyed the people. So that lets me know that I have that simple random sample. And it actually tells me I surveyed 81 people, which means I have a sample size greater than 30. So I've met the two conditions. It continues on and it gives me the sample mean wait time, which was 8 hours. It gives me the sample standard deviation of 4 hours. And then it asked me to construct a 90% confidence interval. So everything that I need to solve the problem is given, because I need, remember the information you need. You need the sample size, you need the sample mean. In this case, you're going to get the sample standard deviation, and you need the confidence level. So I was told that I sampled 81 people. The sample mean wait time was 8 hours. The sample standard deviation is 4, and the confidence level is 90%. Now, if you were doing this on quiz 6 or on the midterm that's coming up, you would have to pay attention to the fact that you are given the sample standard deviation, because that is my clue that I need to do a T interval. The fact that I do not have the population standard deviation, but instead have the sample standard deviation, that is the clue or the alert in my problem that I'm going to do a T interval. And again, on the quiz and on the midterm, you have to make that determination about which one you're going to calculate. Okay, and so that's how you tell the difference. Do you know the population standard deviation, or do you know the sample standard deviation? In this case, it's the sample, so you want to do the T interval. Okay, so I have all of my information gathered, so I'm going out to Minitab. We go Stat, Basic Statistics, and we're doing one sample T. We have the summarized data. We're outright given the sample size, the sample mean, and the standard deviation. So I choose summarized data, and then I enter the information. The sample size was 81. The sample mean was 8. The standard deviation, or the sample standard deviation, Minitab just calls it standard deviation, was 4. Then we go to options. I have to indicate my confidence level, and for this problem it was 90%, and my alternative hypothesis is always not equal. I'm not worried about whether it's less or greater than. I'm just worried about whether or not it's the same or equal. I click OK twice, and just like we were getting last week, in our upper screen we get the results, and I'm going to copy them over here to my paper so we can talk about them. Okay, so here are our results. Again, just like it did before, it gives you the mean, the standard deviation, and then it gives you the interval. So the interval that it gives you is 7.260, 8.740. Remember that the first number in the parentheses is your lower bound, and the second number is your upper bound. Okay. Then I need to calculate, and this is one of the few things that we have to calculate by hand, is our error bound margin. Okay. So our error bound margin is the upper bound minus the lower bound divided by 2. Remember that you have to do the subtraction in the numerator first. So I'm going to use my handheld calculator. 8.740 minus 7.260 is 1.48, and then that divided by 2 is 0.74. So my error bound for the mean is 0.74. Then lastly, we write our conclusion. And again, it's pretty much the same phrasing as we had before. We estimate with 90% confidence that the true population mean wait time is between 7.260 and 8.740 hours. Okay. So again, we're just filling in the blanks. I'm using literally the exact words that were on the slide. And let me tell you what slide number it was. On slide 6, and I'm filling in the blanks. We estimate with 90% confidence that the true population mean. Guys, those words are important. We talked about that last week. You have to have the words true population mean, and then whatever the variable is, in the conclusion. That's why I capitalized them. Those words are important. Questions before we move on? The other scenario that you can see with a T, just like we saw with the Z, is you can be given the raw data. You can be given the list of data values as opposed to the summarized statistics. So this question says, you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, assumed normal, from which you took the data. A couple of things I want to point out here. One is, it does tell us that we have 12 subjects. Now, it doesn't explicitly say randomly selected or randomly sampled. We can make that assumption. Again, in this course, we would do that. The other thing that it does here is it inserts this statement, assumed normal, because in order to meet the two original conditions, we can assume there was a simple random sample, but our sample size is less than 30. So we need to know that the population was approximately normal to start with, and it does tell us that in the problem. Beyond that, it tells us to construct a 95% confidence interval. So in this format, when you have the raw data, we know the sample size because it tells me, but also I could count how many data values we have. I don't know the sample mean, and I don't know the sample standard deviation, but I know the confidence level is 95%. Okay, this is kind of at the moment is unknown, but hopefully you realize we have the data, so we could calculate it should we need it, but I don't necessarily need it to work the problem. I do need the raw data. So I scribbled it down on a piece of paper earlier so that we can take it over to Minitab. Okay, so I'm going out to Minitab, and this time I have to enter the data. Okay, so this represented the sleep time, or the amount of sleep, how many hours of sleep they got. Okay, so if I enter my data, 8.2, 9.1, 7.7, 8.6, 6.9, 11.2, 10.1, 9.9, 8.9, 9.2, 7.5, and 10.5. Okay, I noticed that my last number I did put in was on the 12th row, so I know I've entered 12 values. I can double check, kind of skim through, make sure I didn't enter something wonky. Okay, so now I have the raw data, not the summarized statistics. So I go to Stat, Basic Statistics, 1 sample T, but I have 1 or more samples in each column. 1 or more samples. I don't have the summarized data, which is my sleep time. So I choose the variable that's in the column. I still have to go to options to indicate what confidence level I want, which in this case is 95. And my mean, my alternative hypothesis, should always be not equal. And I click OK. And I click OK. And again, the results appear in the top half of the screen. I'm going to copy it and take it over here to my paper. Well, you gonna let me paste? Uh-oh, where did it go? Okay, it got pasted up here. Let me see if I can move it down. Okay, so notice we actually get the information that we were missing in the Minitab output. Again, if you needed it, it gives us the mean. So I now know that the mean for that 12 pieces of data is 8.983. My sample standard deviation is 1.290. Now I still don't really need to know that, but Minitab calculates it for me anyways. What I do need is my upper bound and my lower bound. So it's 8.163 is the lower bound, 9.803 is the upper bound. That's given right here. I then have to manually, with my calculator, calculate the error bound for the mean. It is the upper bound minus the lower bound divided by 2. Again, please, please, please remember you have to do the subtraction first. So 9.803 minus 8.163, whoops, is 1.64 divided by 2 is 0.82. So my error bound for the mean is 0.82. I then write my conclusion. We estimate with 95% confidence that the true population mean, and let me make sure what the variable was, mean number of hours slept, mean number of hours slept is between 8.163 and 9.803 hours. And there you have it. Do you have questions? Okay, for the T interval, we do not do sample size estimation because we're already using a sample since we know the sample standard deviation. So we do not do sample size estimation for T intervals. Okay, I'm going to switch gears now. The third type of confidence interval that we're going to talk about is a confidence interval for a proportion or a percentage. Okay, so far we've talked about Z intervals for the mean, T intervals for the mean. We're now going to actually talk about Z intervals for a proportion or a percentage. But again, the procedure itself to find that confidence interval, the sample size and all that is very similar. It's just that the formulas are different. And the formulas in some way look messier or a little bit yuckier than they did for the Z and the T for the mean. I did make a note over here to the side. We do a confidence interval for the mean with the known population standard deviation. We use the normal distribution or a Z interval. When we want a confidence interval for the mean with an unknown population standard deviation, we use the student's T distribution and we would do a T interval. I mention that because when we're dealing with a proportion, the distribution that we use is actually a binomial. And I'm not going to get too detailed about this, but one of the ways that you recognize that you're likely going to do a proportion, a confidence interval for a proportion, is that there will be no mention of the mean or average in the scenario. But typically what you are given is the number of trials or the total number of things in your sample, and then how many of those actually occurred. Okay, so the binomial, we have to know the number of trials, how many times do we perform the experiment, and then we have to think about the probability of success. Again, that's kind of underlying, it goes on behind the scenes, but just so you know that if you were ever asked which distribution are you using for the mean, where you know the population standard deviation, we use the normal. For the mean, when you do not know the population standard deviation, we use student's T. And if you're dealing with proportions, we're going to use a binomial distribution. which is kind of weird because we actually approximate that binomial distribution using a normal. But again, that's something that goes on behind the scenes. A couple of new formulas and a couple of new terms. Our point estimate has previously been our sample mean, but now we're going to have a point estimate for the proportion. The notation for that is the letter P for proportion, if you want to think about it that way. And then it has like a little tick mark. Okay, it's read P prime. And to calculate that point estimate, it is the number of individuals in the sample who are in the specific category that we're interested in. The number of individuals in the sample who are in the specific category that we're interested in divided by the sample size. And those two pieces of information will be given in the scenario so that we are able to calculate the point estimate, or P prime. You may not remember, so let me kind of give you a couple of notes here. If you go back to the binomial distribution, remember we used the letter P was the probability of success. The letter Q represented the probability of failure. And a success means you get what you want. Failure means you don't. And so the little prime just indicates that it's an estimate based on the data that we've been given. But also remember that we know that the probability of success plus the probability of failure have to total to 1. And so P prime is like our probability of success for the sample that we are considering. You have Q prime, and sorry, I left off a notation there. I'll have to fix that. Okay, Q prime is 1 minus P prime, which would represent the probability of failure for that specific example. The notation for the error bound for the mean changes slightly. It becomes E, B, P. P is for proportion. So it's the error bound for the proportion. Okay, so you're going to need to know the formula for P prime, and eventually you will need to know the formula for Q prime, which is 1 minus P prime. Okay, these are actually considered Z intervals because even though it's based on a binomial distribution, that binomial distribution is approximated by a normal distribution, and the interval that's connected to the normal distribution is called a Z interval. So we call it a Z interval for proportions. And you're going to be told the number of successes in your given sample, the sample size, and the confidence level that you're trying to create. And we really are only going to consider one type of problems here where we are given the summarized data. I do have the instructions for Minitab. Again, the biggest difference here, there's two differences, is that you're going to choose one sample proportion, because now we're dealing with percentages or proportions, and there's an extra selection that we make on the options screen because we have to tell it that we want it to do the normal approximation. And we do have to calculate our error bound for the proportion by hand. And that formula, though, doesn't change. It's still the upper bound minus the lower bound divided by 2. The statement of our conclusion doesn't change, except for we say the true population proportion, not the mean, in our conclusion. We refer to that population parameter, and the parameter is a proportion. Okay, so slightly different formulas, same idea. Okay, so again, we have some examples, and I carried them over to a Word document so we could look at them together. It says, suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they have cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of this city who have cell phones. Now, a couple of things, as I'm reading through that again, I need to be able to recognize that I need to use the Z interval for proportions. Well, 2 things jump out at me. One, nowhere in this statement or scenario does it talk about mean or average. It does, however, in the first sentence, make a reference to a percentage. So the fact that it doesn't indicate anything about average or mean, and that it mentions a percentage, are my clues that I need to do a Z interval for proportions. When I am doing a Z interval for proportions, I need 3 things. I need the sample size, I need the number of successes, and I need the confidence level, all of which were given in the problem. Okay, because if I go back and read, it tells me 500 people were randomly selected, or 500 randomly selected adults were surveyed. Okay, so I have 500 people that were surveyed. So my sample size is 500. It tells me that 421 of them responded, yes, they have cell phones. So that was what I was interested in, and whether or not they had a cell phone. And then it tells me to do a 95% confidence level. So based on information from the scenario, I know that, Catrice, you have a question?
Yes, ma'am. What did you say that showed you that it was the Z interval? Did you say it was the percentage?
Well, what showed me that it's going to be the Z interval for proportions is, one, nowhere in that paragraph does it talk about the mean or the average, but it does talk about the percent.
Okay.
So that's the clue.
Okay, thank you.
My confidence level is given as 95%. Okay, so we have our sample size, we have X, which is our number of successes. We get what we want, and my confidence level is 95%. When I have those 3 things, I'm going out to Minitab. We go to Stat, Basic Statistics, 1 Proportion. because we're doing a proportion, not a mean. One proportion. We have summarized data. Okay, the number of events, and let me go over here and make notes for you. Minitab refers to the number of successes as the number of events. The number of times that you get what you want. So that's 421. It refers to your sample size as the number of trials. How many times did you perform or conduct the experiment? Whoops, wrong symbol. Okay, so those are the phrases used in Minitab. So I had 421 who responded yes out of a total of 500. Again, I go to options. We wanted to do a 95% confidence level. We still use not equal, but we need to change my method to normal approximation. And then I click OK and OK. And again, I get my answers. Okay. So here they give us N. They give us how many times we got that thing, how many yeses we had. So it was 421. Sample P, this sample P here is P prime. Minitab has calculated it for you. It took 421 over 500 and converted it to a decimal. Okay, so the sample P is your P prime. And then you have your interval. So we need those numbers. I have 0.810030. That's your lower bound. The first number is the lower bound. And my second number is 0.873970. Okay, these are percentages expressed as decimals. So if you needed or wanted them to be actual percentages, remember you take the decimal and you multiply times 100. So as percentages, we would have 81.003% and 87.3970%. Now, I haven't looked, I can do that, but I haven't looked to see how your quiz or the midterm asks you to express it, whether it wants it in a decimal form or whether it wants it in a percent form. Okay, so I'll try to look for you in just a minute when we get through the lesson. So then we calculate our error bound for the proportion using the same procedure we had before. It is the upper bound, and I'm doing it with decimals, minus the lower bound, and that whole thing is divided by 2. Please remember, you have to do the subtraction in the numerator first. 0.873970 minus 810030 gives me 0.06394 divided by 2 is 0.03197. Again, that's in decimal form. If I convert it to a percentage by multiplying by 100, I would have 3.197%. Okay, so my error bound for the proportion, excuse me, is 3.197%. Then you write your conclusion. It's pretty much the same wording. With 95% confidence, we estimate that the true population proportion what was it a proportion of? Proportion of adult residents that have cell phones in a large city is between 81 oh goodness. Okay, my words got all messed up, so hold on. There we go. Is between 81.003% and 87. Is that it? 87.397%. And there you go. Again, thinking about that conclusion, you got to say true proportion and our true population. In this case, we use the word proportion instead of the mean because we're dealing with a proportion. Okay, I want to skip down, skip the next example, and we'll come back to it if we have time, but I want to talk about how to estimate the sample size for the proportions. Okay, so let me get to that here. Okay, we can estimate the sample size for a proportion. It's kind of the same idea as we had before. We do have to find our special critical value. Again, the most popular being 90, 95, and 99%. Okay, we can base that off of what we're told in the problem. So the formula is we take the Z value from the table, square it, multiply it times the population proportion estimate times the Q, all divided by the error bound proportion. Okay, so this is the formula. It looks yucky, but it's really not as bad as it looks. Okay, it's not as bad as it looks. We're going to get Z. Let's read it and I'll walk you through it. Okay, let me write down that formula there. So we have N equals Z over alpha times P prime times Q prime over the error bound proportion squared. Okay, so let's read through the problem. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 who use text messaging on their cell phones. How many customers aged 50 should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 who who use text messaging on their cell phones? Okay, so again, they tell me initially here in the problem that we're doing 90%. So I know that my Z, whoops, let me get back to I know that the Z alpha over 2, my critical value, corresponds to the 95% confident level because it tells me that in the problem. It also tells me in the problem that the estimated sample proportion is within 3 percentage points. That within 3 percentage points tells me my error bound proportion. So it's 3. Okay, and let's see what else. Okay, the one piece that we're missing here is we're trying to figure out the sample size, but it doesn't tell me my probability of success. It doesn't give me P prime or Q prime. Okay, so when you're not given, see, we don't know P prime or Q prime. They're not given. If they're not given, the rule says we're going to use 0.5 or 50%. Okay, basically you just divide it in half. There's a 50% chance of success and a 50% chance of failure. If you're not told, that's how we divide it up. Okay, so I need to go back out here to my table because I wanted 90%. Okay, so 90%, my critical value is 1.65. So based off of my table, I know that Z alpha divided by 2 is 1.65. And then it becomes a plug and chug. Okay, plug and chug. I know that Z sub alpha over 2 is 1.65. And I'm going to square it. P prime is 50%. Q prime is 50%. And my error bound for the proportion is 3. That was given to me in the problem, which is squared. Okay. You can do all the calculations in your calculator at one time. Again, I would tell you to break it apart. So I'm going to do 1.65 squared times 0.5 times 0.5, which gives me 0.680625. 3 squared is 9. So 0.680625 divided by 9. Well, that don't make any sense. Okay, I get 0.0750 625, but that doesn't make any sense because that says I would have to choose less than 0 people or only one person. That doesn't make any sense. So Miss Ralston must have an error. Oh, I know what I did. I know what I did, guys. This is 3 points. Okay, my airbound percentage. I know what I did. Miss Ralston found her mistake. This is 3%. So I should change this to a decimal. I'm sorry, it's my fault. Okay, so 0.03 squared is 0.0009. Now that'll make sense. 0.680625 divided by 0.0009. Yeah, that makes more sense. Sorry about that. We get 756.25. So we would need to survey, remember we always round up, about 757 people. All right, let me go back. Let me backtrack and show you where Miss Ralston made her mistake. It does say 3 percentage points. Okay, but remember that's percentage. So this is 3%. So I need to convert 3% to a decimal. So let's make us a little note here on this formula. Let's see, and say that this needs to be in decimal form. Okay, your airbound for the percentage needs to be in decimal form. It was stated kind of in whole number form, and that's where I made my mistake. Y'all with me? You okay? Questions? I think that was the last example. It was. Okay, so that finishes the content related to confidence intervals. We actually talked about 3 different types. We talked about Z intervals for the mean. We talked about T intervals for the mean. And we talked about Z intervals for a proportion. So on quiz 6, okay, when you look at quiz 6, let me see if I can get out to it. It looks like it's there's lots of questions because it looks like there's like 72 questions. But remember, a lot of them are given in the problem. Okay, now let's look at this first problem right here for just a minute. Can you guys see it? Because it does something kind of weird. It says, among various ethnic groups, the standard deviation of heights is known to be approximately 3 inches. We wish to construct a 95% confidence interval for the mean height of male Swedes. 48 male Swedes are surveyed. The sample mean is 71 inches, and the sample standard deviation is 2.8 inches. Guys, look, this problem, in fact, let me copy it over here onto the paper. This problem actually gives you both the population standard deviation and the sample standard deviation. It's obvious that it gives you the sample standard deviation. It's the last sentence, and it clearly says the sample standard deviation is 2.8 inches. But guys, you got to be careful, because back up here in this first sentence, it says the standard deviation is known to be 3. Okay, remember, Minitab calls the population standard deviation the known. It doesn't literally say population standard deviation, but the fact that it tells me it is known is a clue that this is the population. So this problem gives me both the population standard deviation, which is 3, the sample standard deviation, which is 2.8. It also tells me the sample mean is 71 and that we surveyed 48 males, and we're going to do a confidence level of 95%. So your first question should be, most likely, well, should I do Z or should I do T? Guys, here's the deal. If you know the population standard deviation, you have to use it. So because I know the population standard deviation, I would actually do a Z interval for the mean in this problem. The fact that I know the sample standard deviation is simply extra information that I do not need. Now, again, it seems like this is a much longer assignment, and I guess it is, but guys, a lot of it's given to you in the problem. Population standard deviation is 3. The sample mean is given in the problem and is 71 inches. The sample size is given in the problem and is 48. The confidence level is given in the problem is 95%. You then have to calculate the lower bound, the upper bound, and the error bound margin, and then you have to choose the correct conclusion. I did not write these problems, so they don't use the proper verbiage. Okay, so the problems look lengthier, or the lesson looks lengthier because there's 72 questions, but that one question had 8 questions, and of the 8, 4 of the 8 are given to you in the problem. Okay? Y'all with me? So here's what I would suggest should you have the time to do it. Okay? We have finished the content. So I would recommend, if you have time, go ahead and take a look at quiz 6 in case you have questions. Also attached to the week 7 announcement is a midterm study guide. It would be great if you could take a look at that. It gives you information about the midterm. It kind of gives you a layout of the questions. There are 5 true false, 5 fill in the blank. There are 12 questions related to quantitative data. There is a question on a binomial distribution. There's 5 questions. There's 5 questions related to uniform, 5 questions related to exponential, and then 2 questions on confidence intervals. Okay, so that gives you kind of information on the layout. You do not have access to Minitab during the midterm because we're using Respondus Lockdown Browser. So I have the Minitab output embedded with the question, sort of like how I copy it over onto our Word document. You're going to have that printout, this printout displayed with the question. So you primarily need to know how to read the output. I also give you suggestions, very strong suggestions of things that you need to put on your cheat sheet, because you are allowed one 8.5 by 11 sheet of paper with notes on it, front and back, handwritten notes, and it says that up here. One 8.5 by 11 sheet of paper with handwritten notes, front and back. And Miss Ralston gives you a very lovely list of things that she strongly suggests you put on your paper. If Miss Ralston says, put it on your paper, put it on the paper. Okay? So Thursday, I hope you guys will come with maybe some questions related to the midterm exam, even if it is just like, okay, I don't remember how to do this, or I don't remember how to do this. I'll try to compile some example problems to have nearby so that I can work out examples for you so that you can get yourself prepared for the midterm. The midterm opens Monday, the 3rd of October, and will close on Saturday, the 8th of October. And we'll talk more about it, talk more about that on Thursday.